Okay, so we have this integral function right here which we've been asked to evaluate. Okay, so I'm going to just proceed right away to solve it, but just before we continue, you can actually do well to subscribe to our channel if you've not done that. And then of course, having written my solution, I'm going to rewrite the equation. This is integral x minus 8 divided by x squared plus 3x and then plus 2 dx. Okay, so what I'm going to do first is actually to evaluate this fraction right there. So I'm going to split it by partial fraction. Okay, so if I do that, x minus 8 divided by x squared plus 3x plus 2 can also be written as x minus 8 divided by. Okay, so what I'm going to do to factorize this, I will look for two numbers that when I multiply it, it's actually going to give me 2. And then when I sum it, it will give me 3. Okay, and the two numbers are just 2 and then 1. 2 times 1 is actually 2, and then 2 plus 1 will give you 3. So having gotten that, I'll just simplify this as x plus 2 right here. Okay, bracket x plus the remaining number, which is 1. Okay, so that is what I have. And then I can also simplify this. If I now want to put this in partial fraction, I'll have that x minus 8 x squared plus 3x plus 2 will now give me a divided by the first term right here, x plus 2, and then plus b divided by the second term, x plus 1 rather. Okay, so what I'm going to do again is to go ahead and find the LCM of this stuff right here, and then I will solve this. I will simplify this fraction right here. If I do that, I will have that x minus 8 divided by x squared plus 3x plus 2 is equal to, okay, so the LCM here is actually x plus 2 and then x plus 1. And so this divided by this will cancel this and this will remain. So I'll just use it to multiply this. That is a into x plus 1. Okay, plus b into, of course, this will cancel this will remain, into x plus 2. Okay, now I'll move further by equating the numerators here since the denominators are equivalent. So what I'm going to be having is that x minus 8 is equal to a into x plus 1, and then plus, this is plus rather, b into x plus 2. Okay, to obtain the value of a and b, first I will just put x, I'll substitute x equal to minus 1 so that I can remove this one and then I'll get my b. So if I put that, this is minus 1 right here, minus 8 is equal to a into minus 1 plus 1, and then plus b into minus 1 plus 2. Okay, so you can clearly see that minus 1 plus 1 here is 0, and 0 times a is actually 0. So here I'm going to be having that this is minus 9, okay, is equal to, so if I simplify this is 2 minus 1, which will give me 1. 1 times b will give me b. So clearly b is equal to minus, which implies that b is equal to minus 9. Okay, to get my a right here, I'm going to put x to be equal to minus 2 so that this one becomes 0, and then I will evaluate this one over here. Okay, so if I put it right here, this is minus 2 minus 8 is equal to a into minus 2 plus 1, and then plus b into minus 2 plus 2. Okay, so clearly you can see that this one is equal to 0 because minus 2 plus 2 is 0. 0 times b is 0, and then here this is minus 10 is equal to minus 2 plus 1 will give us minus 1, and then minus 1 times a. Clearly you can see that a is equal to 10 if I multiply through by minus, so a is equal to 10. Okay, so having gotten all of these things, I can now come over to this place I splitted the fraction and substitute the value of a and b. Okay, so my fraction is now going to be something like this. So this is actually going to be, okay, so this is x minus 8 divided by x squared plus 3x plus 2 will now give me a is actually 10. over x plus 2, okay, and then minus b is minus 9, so I'm going to be having minus 9 into x plus 1. So this is what I'm going to be having. And then if I put integral right here, and then this implies that I'm going to be integrating all of these things. Okay, if I put the s here, I'm going to also be putting the x over here. So what I'm going to do is just to pass the integral into all of these things, and if I do that, I'll have that this is equal to the integral 10 over x plus 2, okay, the x minus integral 9x divided by x plus 1 dx. Okay, so this is what I have right now. Okay, I can continue, but if I can factorize this 10 right here, so I'm going to be having 10 into 1 over x plus 2, okay, the x minus 9 into integral 1 over x plus 1 dx. Okay, so here clearly you can see that if I integrate this is actually going to give me 10 ln x plus 2, okay, minus 9 ln x plus 1 plus the constant of integration. Okay, so this is actually going to be our final answer.